Hello, Dr. Grissom. This is Timothy Alec and Vincent Malara's submission for the Lab 2 BLE server and client. So here let's restart them real quick.
I don't know which one.
So this one's
That one's the client. This one
is server. So here we're gonna resend the signal, and then now they'll both initialize. So you can see on here this one's blue and this one's red. Hold on.
And on the client code is blue because that's me moving my own dot, so it's blue. But then on the server code it is red. And then if I go to the server code and move my blue dot, it shows up as red on the client code and blue on my own code. And you could both move the dots at the same time. The data transfers and everything, everything's flawless. And then if you perform a collision on here, both games end. And that's how it goes.
That's the demo. Perfect. And then now we'll go into code review for the server and client.
Can you go over our server code? So this is our server code. We're using M5 Unified. I switched to that instead of the M5 Core. So what we do is we have our default characteristic, which I changed to characteristic red, and then we introduce a new one called BLE characteristic blue dot. So this characteristic is used to read whatever the client is sending us for the blue dot coordinates. Because previously we just had one characteristic, and that characteristic was us sending our data for red over to the client. And then we just have our screen initializations here, the default game mechanics for the button and the joystick, player movement speeds. And then this is our new UUID for the blue dot, which we would send to the client and vice versa. And then we have the same callbacks for initiating the connect or device disconnected. And then down here is when we have our on read and our on write function. So this is very important for transfer of data in between the client and the server. So on read is when the client just reads from us. And so we're sending the characteristic UUID from the BLE characteristic callbacks. And then on write is when the client writes to us. So this is when the blue dot comes in. So this is very important because we were working on it for a while, and the blue dot wouldn't move on the server code, but it would on the client. So we had to create a read so that the server could read from the client, and we have the read value right here. So this is what the client would send to the server, which is the coordinates, and then we have a function to parse it and then display the dot based upon these coordinates. And then down here is if the UUID is equal, it'll separate it with these commas, and then it'll use those commas to separate the red X, the red Y, the blue X, the blue Y, and then the collision. We also send the collision to the client. That's handled by us. It's a Boolean, which is initiated up here. Collision equals 0, which is not. And then if there is a collision, it'll equal 1. I believe collision is down here. So if the blue X minus red X and blue Y minus red Y get with and reinitialize those, and then if they get within a certain collision distance of each other, which is a set variable, we change the collision Boolean to 1, and then we fill the red screen red, blah, 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 saying game over, and then we also send the string data, which is the coordinates for the blue X and all the coordinates for the blue and red dot. And we send that to the blue characteristic red, which is set the value for that string. And then we print that it's been set to the client, and then the client receives that, and then it shows the game over screen for it. And then we also have a milliseconds delay right here to send the data over for the blue characteristic dot red. And then I believe this was already here from just the regular server and client code. Draw the screen, broadcast the BLE server. We created a new broadcast for the blue dot, and then and then Yeah, that's all we added for the blue characteristic blue dot. Now, Vince could talk about some of the client code.
Alrighty.
You can use the mouse.
All right, so
I'll go over on this side.
push this out.
Yeah.
Oops.
Oh no, you're good.
Okay, so here, same thing as before. We have these global variables and UUIDs. So this blue char UUID is the same as what was in the server. And then we also have the BLE broadcast name. So this is what we're gonna scan for when we're looking for the server. And then this is gonna be the addresses that we're looking for the gamepad QT. Here we initialize the seesaw, and then we just set the pins for the different buttons that we have. So X, Y, A, B, select start, all that. And then here is these are just the functions that we call up here, and then the implementations are below. And then we have this parse and draw dot, which is called by the client because we want to get in the X and Y coordinates from the server and then draw that as a dot here. So this is called within our loop function. And then we're essentially just getting the red X, red Y, blue dot, blue X, blue Y, and their speeds, and then collision. And then right here, we're just scanning to see or we're going to clear the screen and then draw the dot based on these conditions. And then here we have this is the same function as before. We're just going to check if we're connected and then set device connected to true or false based on that condition. And then here we want to connect to the server. So here is where we instantiate a BLE client. So you can see here we have BLE device, and we call create client to create this BLE client. And then we want to set our callbacks, and then just print to serial that we've created the client. And then if the client is not connected to the remote server, then we want to say it failed to connect to the server. Otherwise, we're going to say it connected to the server. And then we want to also find the service. And then if the remote service is a null pointer, then we're going to say that we couldn't find our service UUID. Otherwise, we're going to say that we found our service UUID. Here, it looks a little, yeah, maybe like this or something.
Oh yeah, that's kind of better.
Okay. And then we also want to, so we're connecting to the server, finding the service, and then here we also get the characteristic. Again, we check if it's a null pointer. If so, we failed to find our characteristic. Otherwise, we found our characteristic, and then we also have a characteristic for the blue dot, where we're just checking to see if we could find the characteristic for the blue dot. So
then advertising.
Yeah, right here.
Yeah.
Yeah. So my my advertised device callbacks is just going to check for the advertised devices found. So we're just going to print to serial the advertised device as a string, and then we're going to check if the name and the service match up. So if the service UUID here and the advertised device service UUID is equal to the broadcast name, then we are going to connect to the server. And then here we have setup. So here we're going to begin the M5 device, set our text size, begin wire, and then set our clock rate. And then we're going to draw screen text with background, scanning for BLE server with pink. So that's when the device is set up. We're going to just check to see if we can find the server. And then if we can't find the gamepad QT, we're going to say seesaw not found. Otherwise, we're going to initialize the device and then start the timer. And then here we initialize our BLE device. We start scanning. So we start a scan, and then we set the callbacks. We set interval, window, and then we're going to start. And so that's everything that's run in the setup. Setup is pretty small. And then in our loop, here we initialize the joystick values, so joy X and joy Y. And then here, if do connect is set to true, And if connect to server is set to true, we can say that we are now connected to the BLE server. And then we're going to draw the screen with connected to BLE server as green. Otherwise, it's going to say we failed to connect, and it's going to be red. And then if it's not connected, we're going to set do connect to false. And then here, if we lose connection, so if the device is not connected and we're scanning, we're going to say disconnected, but we're rescanning, and then we want to get the scan. And then here we want to read from the server and draw the red circle. So here we're reading the remote red characteristic, and then we're going to draw the red dot based on the server data. And then here's our button mask where we set our buttons for our A, B, Y, and X to control the movements. And then based on what we press for the start speed, we do mod 5 plus 1 to increment the joystick or the speed of the dot. And then we want to draw the blue dot locally based on its X and Y position, and then our fixed dot size so that both dots are the same size. And then we want to also write the blue dot coordinates to the server. And then here you can see that we're writing a value to the server. And then that's pretty much it. And then our draw screen text with background, where you just give it a text and background color, and then it sets the screen. So that's pretty much it.
Thank you, Dr. Grissom.
Thank you. Bye-bye.